You are watching ColdFusion TV.
Hi, welcome to another ColdFusion video. Since Wi-Fi's accidental invention in 1992 by Australian radio astronomer Dr. John O'Sullivan through a failed experiment to detect exploding mini black holes, Wi-Fi has revolutionized digital communication. Without it, our current mobile way of life would be somewhat different. Wi-Fi currently makes up 60% of global internet traffic. With all of that being said, Wi-Fi still has some issues. It's sketchy at times with a varying signal, and it's not totally secure because your signal could travel through walls and be easily picked up by someone else. The reason for all of this is that Wi-Fi uses radio waves to transmit data. So how do we improve this technology and solve these problems? We must use something that's cheap, safe, plentiful, and more robust for data transfer. The answer? Light. Light is perfect because it's actually just part of the electromagnetic spectrum, just like radio waves, but at a much higher frequency. That is, the waves that carry the energy cycle at a much faster rate than radio waves. Light also has a frequency range 10,000 times greater than radio waves, going up to 790 terahertz versus a maximum of 300 gigahertz for radio waves. All this means is that light has the capacity to transmit vastly more pulses of data in much less time than radio waves. The concept of light being used as a medium to transfer internet data has been coined Li-Fi. Let's hear a bit more from Harold Haas, the founder of Li-Fi, in a TED Talk from 2011, right at the technology's infancy.
Light bulbs installed already. So we have the infrastructure there. Look at the ceiling. You see all these light bulbs. Can we use them for communications? And there's one thing we need to do is we have to replace these inefficient incandescent light bulbs, fluorescent lights, by these new technology of LED light bulbs. An LED is a semiconductor, it's an electronic device, and it has a very, very nice and cute property. Its intensity can be modulated at very high speeds, and it can be switched off at very high speeds. And this is a fundamental basic property that we exploit with our technology.
So how does this all work?
You all know the remote controls have an infrared LED. Basically, you switch on the LED, and when it's off, you switch it off, and it creates a simple low-speed data stream in 10,000 bits per second, 20,000 bits per second, not usable for a YouTube video. What we have done is we have developed a technology with which we transmit with our technology not only a single data stream, we transmit thousands of data streams in parallel at even higher speeds.
In another part of the talk, Haas does a pretty cool demonstration. He fits a desk lamp with a normal LED bulb worth about $3. A software code makes the bulb flicker at extremely high speeds. This flickering, or pulsing, is then converted into a signal by a receiver, and then watch what happens next.
So what happens when I switch on that light? As you would expect, it's a light, a desk lamp. You could put your book beneath and could read. It's illuminating the space. But at the same time, you see this video coming up here. And this is a video, high-definition video, that is transmitted through that light beam. You're all critical. You say, this is a smart academic doing a little bit of tricks here. But let me do this. Once again, it is this light that transmits this high-definition video, this bit stream. And if you look at the light, it is illuminating as you would expect. You don't notice with your human eye, you don't notice the subtle changes in the amplitude that we impress onto this light bulb. It's serving the purpose of illumination, but at the same time, we are able to transmit this data. And you see even light from the ceiling comes down here into the receiver. It can ignore that constant light because all the receiver is interested in these subtle changes.
Harold hopes to integrate this receiver technology into phones and even phone cameras so that they can send and receive high bitrate information through and from light. You might be wondering if the light has to be turned on the whole time to receive data. Haas says yes, but the thing is, you can actually dim the light down so that the human eye cannot detect that it's on, but the receiver still can read it. Okay, so that sounds great, but does it actually work in real life? The answer is yes. Researchers have reached speeds of 10 gigabits per second in lab conditions. For a perspective, South Korea's world record internet speeds are only 100 megabits per second. Li-Fi has also been successfully tested in a commercial context. There's been trials in offices in Estonia that are reporting transmission speeds of 1 gigabit per second, still 100 times faster than current average Wi-Fi speeds. So imagine this, you could walk into any room, switch on the light, and simultaneously instantly have an internet connection 100 times faster than your regular Wi-Fi. But it doesn't stop there. Researchers at the Oxford University have published results of visible light internet at 223 gigabits per second. With those speeds, you could download 18 1.5 gigabyte movies in 1 second. But of course, whether or not the servers will be able to serve those files to you is another story entirely. But still very impressive nonetheless. So what's the conclusion here? We could be seeing very cheap light-powered internet or Li-Fi everywhere. This could easily lead to the Internet of Things becoming a reality, a situation where all electronic devices communicate with each other. From your mobile phone communicating with your fridge, to sensors on a bridge, warning of structural damage and potential failure to civil engineers. If Li-Fi becomes widely available, I believe we would have turned a corner into a technological revolution that would lead to a world where the internet and transfer of information is no longer an obstacle for the average user. So anyway, that was just a quick story I thought I'd bring to you. It's quite fresh because the Li-Fi tests in real life scenarios were only completed 2 days ago, at the time of this recording, so pretty exciting stuff. Thanks for watching, don't forget to leave a thumbs up if you liked it, comment and subscribe if you're new. If you want to know more stuff on cutting edge technology, hang around for the next 10 seconds and follow the prompts on your screen. Cheers guys, this has been Dagogo, you've been watching ColdFusion, have a good one.
ColdFusion. It's new thinking.